welcome to IAS Origin. Today in this video, we will be talking about the newly launched railgun technology. Yes, this is a new technology. It has been launched by Japan. Yes, Japan becomes the first nation in the world which will use railgun technology from an offshore location. Yes, so what is this railgun technology? How it is different from the conventional technologies or the weapons which were till now in use. So in this video, we will be discussing in detail about all this. Before starting on to our topic, I would like to tell you that you can enroll with IAS Origin for Prelims cum Mains program, where you will be getting live classes, weekly test, one-to-one mentorship session, unlimited recorded access, and a personalized strategy plan based on your needs. So, what is railgun? Railgun is a cutting-edge electromagnetic weapon. Yes, it uses the principle of electromagnetism to operate. Yes, it is designed to launch a projectile at an incredibly high velocity, reaching the speed of Mach 7. Mach 7, meaning thereby 7 times faster than the speed of sound. This is a huge speed. This technology is capable of targeting various objects including ships, missiles and aircrafts. Now, conventionally, जो पुराने warfare होते थे, they used to use gunpowder in them, but this will use electricity. This is for the first time that electricity will be used, and it works on the principle. This is a picture of railgun. Here we have used two rails. These two rails are being used, and here in the middle is a armature. ये armature कराता है. Now the magnetic field flows from these rails, from this rail to this rail, in a positive to a negative terminal. This way is connected. Here is one rail and one rail is here. So इन दोनों के बीच में magnetic field pass करती है. And you might have heard of Lorentz rule. Electromagnetism creates a current and a force. Okay, and this force acts perpendicular to the direction of magnetic field. Now these are the two rails and the magnetic field is flowing between these two fields. Now when the magnetic field is this direction, the force will be in a perpendicular opposite direction. As a result, इन दो आर्मेचर के बीच में जब भी मैग्नेटिक फील्ड आएगी तो फोर्स इस डायरेक्शन में लगेगा एंड यहाँ से आर्मेचर निकलता है. And this way, the armature slides off and the railgun works. So this was the principle of electromagnetic railgun, which is being developed by Japan. So now let's look into detail. Why is Japan developing it and what are the advantages over the conventional warfare? Now, as I said, the conventional warfare used gunpowder, but this had several disadvantages. गन पाउडर जब ऑपरेट करता था वेपन्स में तो उस वेपन के साथ वो गन पाउडर लोड किया जाता था, देन द वेपन्स वर लॉन्च्ड. नाउ ऑलरेडी द वेट ऑफ द वेपन वाज सो मच एंड ऑन टॉप ऑफ दैट गन पाउडर का भी वेट ऐड हो जाता था. एज अ रिजल्ट वेपन का वेट बहुत इंक्रीज हो जाता था एंड एक पर्टिकुलर अमाउंट के आगे अपन गन पाउडर और लोड नहीं कर पाते थे. बट सिंस यहाँ पे गन पाउडर की जगह इलेक्ट्रिसिटी यूज हो रही है, द लोड हैज बीन रिड्यूस्ड एंड वी कैन डेवलप अ मोर वेटेड रेल गन एंड यूज इट एट अ फास्टर एंड अ बेटर स्पीड. नाउ another is current navy guns have a range of 12 miles. Till now they could have targeted the weapons which were 12 miles away from them. But now, after the railgun technology, the precision has increased and they can hit 250-mile away target. And one more advantage, till now the hypersonic, cruise and the ballistic missile were unable to be hitted. उनकी speed इतनी ज़्यादा रहती थी, they could not be easily detected and hampered. But after the launch of the railgun technology, the hypersonic missiles could also be detected and they could be targeted. And at least at a distance of 250 miles away, the railgun can hit. So this is a huge advantage. But there are also certain problems which have been associated with the railgun. Now these problems are power supply. Now railgun is such a big technology. उसको ऑपरेट करने के लिए इलेक्ट्रिसिटी बहुत ज़्यादा चाहिए रहती है. So the capacitors which are there must have enough storage capacity to store the electrical charge जब तक कि sufficient amount of charge आ ना जाए and operational threshold receive ना हो जाए. So this is a power supply problem. Then is a resistive heating. Yes, whenever current will pass, there will be resistance. रेजिस्टेंस जो इलेक्ट्रॉन्स देते हैं उसके कारण से हीट जनरेट होती है एंड द रेल्स गेट हीटेड अप. This leads to another problem which causes melting. Yes, some parts of the railgun can melt while in use because of the excessive heating and also when the velocity of the armature is high. High force create होता है, high electromagnetic electromagnetism की वजह से, तो इतनी ज़्यादा velocity के कारण melting भी हो सकती है. And another is repulsion. Now, when electromagnetism is there, repulsion होता है, दोनों rails एक दूसरे को repel करती हैं. Now, when they repel each other, इसके कारण wear and tear आता है, and there needs to be a frequent replacement in the parts of the railgun अगर उसको use किया जाता है on a massive scale. So these are some of the disadvantages which have been associated with the railgun. So now let's look into the detail how Japan developed this technology and since when it has been developing. Yes, it is not a new technology but उसके ऊपर testing 1990s से चल रही है. Since the time of 1990, it was started as a smaller prototype 16 mm की railgun बनाई गई थी by the agency known as Ground System Research Center. Ground System Research Center 1990 में पहली बार small prototype बनाता है 16 mm का. Then in 2016, ETLA Acquisition Technology and Logistic Association did a mission and prototype बनाता है anti-air and anti-missile capabilities के लिए. Then finally in the year 2023, Japanese Maritime Self-Defense Force in collaboration with ETLA has successfully test-fired a medium caliber maritime electromagnetic gun जिसको ship से launch किया जा रहा है. And this is a huge achievement. Japan wants to develop this because Japan की एक बहुत ही strategic location है. This is Japan and it has been surrounded by North Korea from here and China from here. Already China के संग उसके South China Sea में इतने सारे issues चलते हैं over various islands like Senkaku, and then North Korea is also over there. North Korea has previously attacked Japan many times, and because of this strategic location, Japan thinks that it should need to develop a well-developed defense system so that it can counter any attacks in future, because China has also developed the hypersonic missile which is even better in technology than US. So Japan wants to counter it. Now, whenever we come to geopolitics, arms race की बात की जाए तो whenever one country increases its arms, the neighboring countries would definitely increase their arms because this is a security dilemma. India अपनी nuclear capabilities को बढ़ाती है to protect itself from the countries like China and Pakistan जो कि दोनों nuclear weapon states हैं. So as to protect yourself, the weapon race has gone always high. कोल्ड वॉर की बात की जाए, जब आर्म्स रेस बढ़ी थी, क्यूबन मिसाइल क्राइसिस, बिकॉज ऑफ द म्यूचुअल सस्पिशन बिटवीन रशिया एंड यूएसए. सो सिमिलरली whenever it is about arms and weapons, technology demonstration बढ़ता जाता है, capabilities बढ़ती जाती है, newer technologies develop करती हैं to protect itself from the other nations and other capabilities, and now it has emerged as a showcase of your technology and research and development. So Japan is the first country to launch the railgun, which is a newer technology and definitely a better technology than conventional warfare, with a huge scope, huge precision and huge velocity. It can counter all the missiles that come in its way, and this is a technology far better than those developed by US, because US in the past has tried to develop railgun but failed in its attempt, and as a result dropped the plan in 2020. India has also been working on it, and DRDO is planning to develop a railgun and a small prototype has been created. So let's hope for the best that we'll be able to get success in this railgun technology. That was all about railgun of Japan. I hope you liked the video. Do like and comment, and for more such videos, please subscribe to our channel IAS Origin. Thank you.